Algebra 1 students, welcome to your 1.7 notes. Today we're going to focus on the distributive property. It's a property I think you've seen before in previous courses, but it's worth a little time to review. So let's get started. On this first slide here, you just see the property. This actual diagram is just copied straight out of your book, so you can read through it, but basically it's showing you different ways the distributive property would look with variables or with numbers. And you can see sometimes we have a number at the beginning, sometimes it's at the end, sometimes we have addition in the grouping, sometimes we have subtraction, but you got several different options. So let's go ahead and give it a shot of using the distributive property. On our first example here, you can see we've got 4 times the quantity of x minus 10. I'm essentially going to take that 4, multiply it by x, and I'm going to multiply it by 10. That gives me 4x minus 40. On number 2, we have basically the same problem, or same type of problem. The only difference with it is that the 3 is behind the grouping instead of before, but it's the same idea. We take 3 times z and 3 times 12, and we get our result, 3z plus 36. On the third one here, it's again same idea, 4.1 times 3x and 4.1 times 8. Even if you don't love multiplying decimals, you can do 4 times 3 is 12. 1/10 of 3 would be 3/10, so 12.3x. And then 4 times 8 is 32. 8 times 0.1 is 0.8, so 12.3x minus 32.8. Go ahead and pause the video. Try 4 and 5 on your own. All right, you can see the answers on 4 and 5 now. Nothing too crazy on either of those. On 4, we did have to do 6 times 1/2. Fraction, whatever, no big deal. On 5, this number outside here was a little larger with a 14, so 14 times 3 is 42, 14 times 5, 70. Again, we're not using a calculator, but I'm pretty convinced you guys can figure that out, even if that means you need to write it and figure it out by, multiplication and take it one step at a time, but that's fine. All right, so let's take a look then at our next page. We're going to use some similar principles to do to simplify some fractions. So on number 6, we've got 7x minus 8 divided by 4. I'm going to first rewrite this as 1/4 times 7x minus 8, which would be the exact same thing, just a different way of looking at it. And then when we distribute, 1/4 times 7x would be 7x over 4. 1/4 times 8 would give me 2. So 7x over 4 minus 2. And I should point out here, 7x over 4 is the same as 7/4 x. So the x can be in the numerator or it can be after the fraction. They're the same thing. All right, number 7, we're going to go through the same process. We're going to take that 1/3 out and do 5q plus 12 inside the grouping. And then we'll distribute. 1/3 times 5q would be 5/3 q. 1/3 times 12 is 4. All right, again, why don't you guys pause the video and try number 8 on your own. All right, you can see my work on number 8 now. 2 minus 4w is what we ended up with. I think that's a pretty straightforward problem. And so we're going to move ahead. Number 9 through 11, we're doing kind of the same thing on all of them, which is simplifying the expression. But you'll notice we're still going to use the distributive property, but this time there's not like a number out there. It's just a negative sign. You could think of it as like a -1 being out there, -1 times 9x plus 5. Or if you're okay with it, you could just distribute the minus sign and we'll get -9x minus 5. Not a lot to that one. That's it right there, -9x minus 5. Number 10, same idea. Take that negative, distribute it to both terms. The opposite of -3x is positive 3x. The opposite of -17 is positive 17. Done. All right. Again, pause the video. Do number 11 and then see if I get it right. All right, you can see number 11, a real quick changing of signs. 9t minus 11 is the result. All right, we're going to use a little different way of doing some multiplication. It's kind of an interesting way that connects us to the distributive property. And we're going to see how we could do something like 7 times 33. Now I know for most of you 7 times 33 might look a little overwhelming as you see it, but what if we broke it down like this? 33, we could think of it as how about 30 plus 3? That's the same as 33, right? And then all of a sudden you have a distributive situation. 7 times 30 plus 7 times 3. Now we know 7 times 30 is 210. 7 times 3 is 21. So you can get your exact answer of 232 without having to use a calculator and without doing the long division that you guys sometimes run into. I don't know why you would do division. That was an interesting statement. How about the multiplication instead? All right, so number 13, 4.93 times 11. This one's a little different approach. I'm going to change the 4.93 to 5 minus 0.07. Okay, so 4.93 is close to 5. I'm going to look at the difference between that number and 5 multiplied by 11. All right, so let's do this. 5 times 11 would give me 55. 0.07 times 11 would give me 0.77, right? 7 times 11 is 77, but we got to move that decimal 2 places, so there it is. And then when you think about this, 55 minus 77 hundredths, you're subtracting just a little bit less than 1, so it's going to be 54.23. All right, why don't you guys, again, pause the video and try number 14 on your own. All right, you can see on number 14, I've actually done this problem 2 different ways. You didn't have to do it 2 ways, but I thought, you know, at 6 2/3, some of you might look at that as 6 plus 2/3. Others might think, well, that's kind of close to 7, so I'll do 7 minus 1/3, and that'll get me there. And when you look at it, you can see either way, I ended up with 80 is the answer. All right, so again, we're still not using calculators, definitely mental math. All right, let's take a look at number 15. A gallon of gas costs $2.94 or $2.94 per gallon. $2.94 would be the other way to say that, of course. Dom has a 16-gallon tank on his car that is 3/4 empty. What will it cost him to fill the tank up? All right, so first thing I'm looking at here is that we have a 16-gallon tank and that it's 3/4 empty. So the first thing I'm looking at is, okay, well, if it's 3/4 empty, that means it's 1/4 full, right? So really no distributive property we're talking about here. And so we're seeing that he has actually 4 gallons remaining. And the more I think about that, I think it would have been better to go ahead and do 16 times 3/4 to say he has 12 gallons gone, okay? That's the part we need right there, 12 gallons, because we're filling it up. So anyway, I don't know why I did 16 times 1/4. Sometimes you outthink things, but I'm just going to roll with it. So here we go. So we need 12 gallons of gas to fill this tank. So essentially the problem I'm looking at is 12 times $2.94. And don't you dare get out that calculator. What I'm going to do instead is say, okay, well, I don't know if I can do 12 times 2.94 in my head, but I can do 12 times 3, and I'm pretty sure I can do 12 times 0.06 or 6/100ths if you want to say it properly. So let's do this. 12 times 3 is, of course, 36 minus, well, 12 times 6 is 72, so this would be 0.72. So the result there would be 72 cents less than $36, or $35.28. Okay. I almost feel like that would be a little bit better question as an estimation problem, but I think using the distributive property has value as well. And that is, in fact, the topic we're studying, so that's what we're going to work with. All right, there's one more topic we need to look at that's somewhat connected to distributive, but it's slightly different. All right, so we're going to take a look at how we can simplify like terms. Like terms are terms that have the same exact variables and exponents with those. So it doesn't mean like this has an x, this has an x squared. Not the same term, okay? Or not a like term. And so if you want to simplify, your like terms need to be combined, and they actually have to be Well, they have to be like, okay? So 17x plus 13x, you notice we have an x and we have an x. Those are exactly the same, so we can go ahead and combine. 17 plus 13 is 30, and we'll still have an x. That's kind of like saying if you have 17 apples and I have 13 apples, how many do we have total? We have 30 apples, all right? Number 17, it's the same concept. Note this time that we have a squared and a squared, so that works for us. We can work with it. We do 8 minus 19. That would give us negative 11, and we still have the a squared hanging out at the end. All right, on number 18, notice we have 3 terms this time, but 2 of them are the same. So I'm going to focus on the 2 that are the same. 9q squared minus 12q squared. I'm going to go ahead and write those. So that's 9 minus 12 gives me negative 3, and we still have the q squared hanging on there. And that 7q, I just have to leave it as is. All right, why don't you guys pause the video again and do number 19. All right, welcome back. You can see what I've done on number 19. Negative 4x plus 16 is the result. I went ahead and kind of color coded things so you can see the x values added up to this, and red, and then in black you had 23 minus 7, which was of course 16. All right, one more slide to go. We're going to look at area of a rectangle. Now remember, for a rectangle you have a little formula. I'm just going to write it over here to the right. You probably remember it, but area is equal to length times width, or you may think of it as base times height. That's the same idea. So here we go. On number 20, the problem says find the area of the rectangle and simplify. Essentially, I just need to take these two sides and multiply them. 8 times 4z minus 5. That might look familiar because all it is a distributive property problem. All right, so go ahead and again pause the video. Do number 21 on your own. All right, number 21, you can see the work there. 35 times 4x plus 1. You did have to do a little distribution. Now, if 35 times 4 is a little more than what you want to deal with mentally, I just did it as saying, okay, 35 times 2 is 70, 70 times 2 is 140. You could use that method we looked at earlier, remember, where we said, like, I could break down 35. Again, we're just doing 35 times 4, so we could do it as 30 plus 5. Times 4, something like that, and then you get 120 plus 20, which is of course 140. So that's a possibility for what you could do if you're struggling with the mental math side of that. Hey folks, that wraps up today's lesson. I hope that you understand what's going on here with the distributive property. We will do a lot of work next time we meet. You guys will get to do some practice. Have a lovely day.